Hello students. So we are here with the next part of the complex numbers. Okay, it is part 4. Again it is from AA and AIHL 1.13. Okay, today I am going to cover the modulus. We have already seen the argument, the polar form, so which is z is equal to r cos theta plus I sin theta, which can be written as r cis theta. Okay. So still the argument is remaining from that part. I hope you are watching my videos. Okay, this is very useful for AA and AIHL 1.13. Okay, then after we finish this whole chapter, then I am going to cover some past paper questions. Okay, so I hope you all are studying well, right? Okay then. So look here, what is an argument? Okay, so for an argument, actually it is the angle. So let me draw x-axis and y-axis. Yeah, this is x-axis, this is y-axis, and we have already covered or already discussed that if z is equal to a plus b iota or a plus bi, then the number, the point p a comma z b represents the complex number z on complex plane. Okay, now on complex plane we don't have x-axis, we have real axis and the imaginary axis. Okay, the real and the imaginary axis. So let me write here r and here I, real axis and imaginary axis. So suppose this is the point P with coordinates a and b, which is the representation of the complex number z. Okay, now this point having coordinates a and b, in this a is the real part of the complex number z and b is the imaginary part of the complex number z. Okay, so I hope you remember this, all this. Now look here, if we want to find the angle made by this theta with the real axis, then what we will do, draw the perpendicular. Now this vertical length is b, the horizontal length is a. Okay, and it will be given by tan theta, right? So tan theta is equal to modulus of b by a. Okay, and this is the representation of OP. Okay, this is the angle made by OP. So OP is representing the complex number z. Okay, so the argument of z, then argument of z written as, we write it as ARGZ. Okay, we write it ARGZ is the angle made by z, okay, or is the angle z where, now look here, this is also very important, the domain of z minus pi less than theta less than or equal to pi. So remember that your answer should be between negative pi and positive pi. Okay, in anti-clockwise direction, okay, we take it positive, and in clockwise direction we take it negative. So I'll show you about the sign convention. Okay, So therefore the argument z is nothing but theta, and theta is tan inverse of modulus of b by a. Now look here, why I am using modulus? Because sometimes your complex number may be in the second quadrant, maybe in the third quadrant, okay, first quadrant, second quadrant, third quadrant, or fourth quadrant. So according to the quadrant, your value of theta will be positive and negative. So we have just now discussed that theta has the domain from minus pi to pi. What does that mean? It means that if you have a complex number in the first quadrant, then of course it will be only theta. But if your complex number lies in the second quadrant, then it will be pi minus theta or 180 minus theta. Okay. So in any form you can write it. But if your complex number is in the fourth quadrant, okay, this is the fourth quadrant, then your theta will be minus theta. So be careful, okay, and this will be that angle. So here this will be the angle with O, of course, theta, and here this will be the angle, so which will be all the way from here to here. And then if your z is in the fourth quadrant, then your theta will be theta minus pi or theta minus 180, because it will be a negative answer. Okay, so be careful about it. So let me rewrite that in a proper way. Yeah, so in the second quadrant, it will be pi minus theta or 180 minus theta. If you write it in degrees, 180 minus theta, otherwise pi minus theta. Okay, so here I have used the sign convention. So look here, again I will repeat this. The argument of a complex number z is given by argument of z, we write it like this, and which is the angle theta, such that tan inverse of modulus of b by a gives you theta. But then the value of theta may be positive or negative, and it depends on the quadrant. Where are you? Whether you are in the first quadrant or second quadrant or fourth quadrant or the third quadrant. Okay. In the first quadrant, it will be theta only, positive theta. In the second quadrant, it will be pi minus theta or 180 minus theta. If you are in the fourth quadrant, then you are going to write negative theta. And if you are in the third quadrant, then you will write theta minus pi, which will be again negative, or theta minus 180, whichever you want to use. So actually the argument is like this or like this. Okay. So here is 180 from above, from anti-clockwise direction, positive 180, and here is negative 180 from clockwise direction. Okay. So let us check some examples. Okay, here are the examples we will solve. So let me write the first one, answer of the first one. Yeah, look here, first I will write theta. So first thing is, what is the real part and the imaginary part? In the first case, A is 1 and B is negative 2. So this one is in the fourth quadrant. So remember it, fourth quadrant. X positive and Y negative in the fourth quadrant. So in the same way, complex number, real part positive and imaginary part negative will be in the fourth quadrant. And then theta is tan inverse of, we will not use of course the negative sign. So negative 2 by 1, which is tan inverse of 2, and let me find tan inverse of 2. I am using degrees for your convenience, just so that you understand it. Tan inverse 2. So my answer is 63.4 degrees. Okay. Now because we are in the fourth quadrant, as theta is in the fourth quadrant, we use negative theta. Okay, negative theta. Look here. Here I have explained in the first quadrant theta only. In the second quadrant pi minus theta or 180 minus theta. In the fourth quadrant we write negative of the theta. And in the third quadrant we write theta minus pi or theta minus 180. So I hope you will remember it. Also notice that your argument is never more than positive 180 or never less than negative 180. It will be between them. Okay. So here we are going to use negative. So therefore argument of Z1 will be negative 63.4. And if you want to draw its figure, it is something like this here. Yeah, Z1. And this is that angle, negative 63.4 degrees. Okay. Now look at the second part of this question. In the second part, I wrote Z2 is equal to minus 3 plus I. So now look here. This is in the second quadrant. So I hope you will not get confused. So here A is negative 3, the real part, and B is 1, the imaginary part. Therefore, theta will be tan inverse of modulus of negative, it is positive 1 over negative 3, but we are going to write it positive. So tan inverse of 1 by 3 and tan inverse of 1 by 3 will be so 18.4 degrees. Okay, but because we are in the second quadrant, okay, so therefore argument of Z2 is equal to 180 minus 18.4. Please note that from this, according to this diagram, we are in the second quadrant. So in the second quadrant, this will be the angle. Okay. And this angle will be given by 180 minus theta, because always we are finding only theta in the first quadrant to avoid the confusion. So it will be 180 minus 18.4, which will be 161.6 in degrees. Okay. So I hope you understood this. Let me solve few more questions before I go to the properties of the argument. Yeah. Okay. Now third part says Z3, the third complex number is minus 2 minus 4i. Let me copy it as it is. Yeah, this is the third complex number. So here, where is it? So I hope you remember it. It is in the third quadrant. Okay, both negative. Real part negative, imaginary part negative. So it will be in the third quadrant. Be careful. So real part is negative 2, imaginary part is negative 4, and therefore theta will be tan inverse of modulus of negative 4 over negative 2. Okay, and it will be tan inverse of 2 because we write it positive. Tan inverse of 2 we already found in the first case. So 63.4. Yeah, let me draw the figure of the second complex number, the argument of the second complex number. So it will be somewhere here, Z2, and it will be this angle. Okay. Now this is in the third quadrant, as I said just now. Here is the complex number Z3, and this will be the angle. But we found only theta, right? So therefore, argument of Z, be careful about it, argument of Z3 will be what? Theta minus 180. So theta means 63.4 minus 180. So which will be 63.4 minus 180, and it is going to give me minus 116.6 degrees. So this is the answer of the third part. The second part was 161.6. The first part was minus 63.4. Now let us find the fourth part. Fourth part is conjugate of Z1. Okay. So let me write fourth part. Yeah, conjugate of Z1. Yeah, right. Now if you remember, let me draw the figure. I have told you that the conjugate of any complex number is the reflection in the real axis. Okay. So Z1 is where? Z1 is in the fourth quadrant, 1 minus 2i, where Z1 is 1 minus 2i. So actually we are here, Z1 is here. So its conjugate will be in the first quadrant, right? Because Z1 conjugate. Let me move this somewhere else. Yeah. So Z1 conjugate will be here in the first quadrant. So let me write Z1 conjugate. And as you know, we just change the sign of the imaginary part. So negative and negative, positive 2i. So therefore it will have the positive angle. Okay. Here theta. So theta is equal to tan inverse. By now you already know modulus of 2 by 1. So tan inverse 2. And tan inverse 2 we have already found 63.4. So this will be the answer of Z conjugate. Okay. Then the next one is Z2 conjugate. So Z2 conjugate I will write here. Now Z2 let me write, where Z2 is, what is Z2? Minus 3 plus I. Now let me draw the diagram for it. Minus 3 plus I is in the second quadrant, Z2. Okay. So therefore Z2 conjugate will be in the third quadrant, right? It will be reflection in the real axis. So this will be Z2 conjugate. Okay. So therefore let me write Z2 conjugate. So we just change the imaginary part. This part will be changed. So minus I. Okay. Now here A is minus 3, B is minus 1, and theta is tan inverse modulus of minus 1 by minus 3, which will be 1 by 3. So tan inverse of 1 by 3, because we are finding first positive and then we are converting it to where it lies. Okay. So tan inverse 1 divided by 3 gives me 18.4 degrees. Now because we are, this is in third quadrant. Okay, please remember it, third quadrant. Yeah, be careful. You have to remember in which quadrant is this. Okay. So please be careful. Remember it. Yeah. So now what I am going to do, I will write argument of Z2 conjugate. Let me check whether I wrote Z1 conjugate or not. Oh, I forgot to write argument of Z1 conjugate. Argument of Z1 conjugate, because it is the same angle, so 63.4 degrees. Sorry for that. Okay. Now here argument of Z, because it lies in the third quadrant, so it will be theta minus 180. It means 18.4 minus 180 degrees. So what it will be? 18.4 minus 180 degrees, which is going to be negative 161.6 degrees. So this will be the answer. Now fourth one I am leaving it for you. Okay, please try in the homework this part. Okay, then I am going to the properties now, though it is not there in your course in IB syllabus. The properties of the argument is not there, but I am writing it for your extra information. Okay. Now these properties say argument of Z1 into Z2 is equal to argument of Z1 plus argument of Z2 and plus minus 2 n pi. What is the use of plus minus 2 n pi? Because if your angle is more than 180, then you can adjust it, add or subtract even multiples of pi. Okay, even multiples of pi. Similarly, argument of Z1 upon Z2 is argument of Z1 minus argument of Z2. Let me write here 2. Yeah. Then argument of Z to the power n is n into argument of Z. Plus minus 2 n pi we are adding with everything. And argument of Z conjugate is minus argument of Z. Now look here. If you look at all of them, these properties are like logarithmic properties. Okay. In logarithm also we write log of a into b is equal to log of a plus log of b. And then you write log of a by b is equal to log of a minus log of b. Okay. And then log of a to the power n, you write n into log of a. And then you write log of a to the power minus 1, you write minus 1 into log of a. So these are similar to the logarithmic properties. So you can remember it, I hope. Okay. Now we'll go to the next part, geometry in the complex plane, because geometry means how to find distance, how to find midpoint, how to find transformation. Okay. So we are going to do that. Right? So look here, I will show you that. Yeah. So first thing is distance. So let P1 represents Z1 and P2 represents Z2, the two complex numbers. Okay. In the complex plane, so suppose let me draw that figure something like this. Real, imaginary, origin. So suppose I have here P1 and I have here P2. Okay. Now what I want to find? I want to find the distance between Z1 and Z2. Okay. So if I have to find the distance between Z1 and Z2, so let us consider the vectors, P1 because earlier I have already told you that we use vector properties for the complex numbers in the complex plane. Okay, yeah, and then okay, now suppose I want to find P2, P1. Okay, from the vectors P2, P1 is given by P2O, right, and minus plus OP1. So these are the two vectors. So P2O is like minus Z2 because this is representing Z2 and this is representing Z1. So from origin to P1 is Z1 and origin to P2 is Z2. So it will be negative of that. So negative Z2 plus Z1, and therefore it is Z1 minus Z2. Okay. So therefore modulus of Z1 minus Z2, which is the distance between Z1 and Z2, is given by the modulus of P2 P1 vector. Okay, this vector which is representing the distance between them. I hope you will remember it. Okay, now in the same way we can find the midpoint also. So look at this. Midpoint. For that, let me draw the complex plane. And suppose this is OP. Okay, OP and OQ. Okay, OP is Z and OQ, let me draw. Yeah, suppose this is OQ. Okay, P is representing the complex number Z, Q is representing the complex number W. So let OP represents Z's and OQ represents W. Now look here, what we will do, we will complete the parallelogram by this. Something like this. Okay, so suppose this is R, the resultant vector. Yeah, now this OR, this is Z, this is W. So we know that OR, the vector OR is equal to Z plus W. Okay, because the adjacent side, sum of the adjacent side gives you the resultant vector. So Z plus W is given by OR, and suppose M is the midpoint here. So therefore OM is equal to Z plus W divided by 2 because it is the midpoint. Okay, this is equal to this one. Yeah, so this tells us that the midpoint of Z1 and Z2 is represented by Z1 plus Z2 by 2. It is similar to the coordinate system. In coordinates also, the midpoint is given by x1 plus x2 divided by 2, y1 plus y2 divided by 2. If you remember it, x1 plus x2 divided by 2, y1 plus y2 divided by 2. So here also we use similar properties. Okay then. Now transformation. Transformation means shifting, okay, or translation. Okay. So what we want to find here? We want to find the transformation which moves Z to IZ. Find the transformation which moves z to iz. I am taking one example just like that. Okay. So let z is equal to x plus iota y. So therefore iz will be I into x plus iota y, and when we multiply it out, it is xi plus I square y, and I square y will be -1, I square is -1 into y, so -y plus xi. Okay. Now look here, let me draw the figure for the complex plane. Okay, this is the real axis, imaginary axis. Now suppose here is our complex number OP, which represents the first complex number z, and then the other complex number which is given by iz is OP dash. Okay, P dash. Suppose what are the coordinates of it? -y, x. Okay. Now look here, what is happening here actually? So here when we are finding the transformation of z to iz, what is happening? Let us see. So this is shifting to this one, right? Now what is the angle between them? It will be exactly 90 degrees. Okay, clockwise. Sorry, anti-clockwise. Okay. Why it is like that? Because the x coordinate becomes y coordinate and y coordinate becomes x coordinate, and the sign of x coordinate changes. So when the sign of x coordinate will change, it will be reflection in the imaginary axis. Okay. And we are going to get P dash, the second complex number. Okay. So therefore this is 90 degrees. Let me draw it here. So therefore transformation of z1 to z to iz is rotation of z by 90 degrees anti-clockwise. Okay. Now again maybe you are still confused why I am writing 90 degrees. So you can check here. See, this angle theta will have the y coordinate x, the x coordinate y. Okay. So if you want to write tan theta, it will be negative of y by x, x by y. Negative I am writing because I am in the second quadrant. Tan theta is negative in the second quadrant. So I hope you know it. And if you want to write this one, so here is y, here is x, and both are positive. So, and let us call theta to this one. Then tan theta 1, the first one is y by x. Now if you multiply both of them, tan theta 1 multiplied by tan theta 2. And tan theta 1 and tan theta 2 gives you the gradient of the line OP and OP dash. So y by x multiplied by minus x by y, and you are going to get -1. So you know that -1 means they are perpendicular to each other. Okay. So therefore it is rotation of z by 90 degrees anti-clockwise. So I hope you will remember this, right? If time will be there, we are going to solve many questions based on it, of course. So let us see the polar form now. Okay. So for polar form means writing it in terms of the angle, right? To write a complex number in the form of its angle. So look here, this figure I have drawn here already. Now look here, let z is a complex number given by a plus b I. Okay. Now let theta is equal to tan inverse b by a. Its argument, suppose, which is the argument, because it is in the first quadrant. So argument of z is theta, right? Now look here, you know in coordinate system that this length, if this length is r, we have already mentioned it in coordinate system, this length is r, this angle is theta, then the coordinates of P will be r cos theta, r sin theta. Why it is like that? Because when you draw the perpendicular here, so it will be opposite side, which will be y coordinate, adjacent side x coordinate. So y upon x gives you tan theta, or suppose if you want to write sin theta, you want to write cos theta first. Here, sorry, cos theta will be given by x upon r. So therefore x is equal to r cos theta. So like this you get x coordinate as r cos theta, and sin theta, how can you write it? Y upon r, opposite upon hypotenuse. So from this we get y is equal to r sin theta. So like that you get the x coordinate and the y coordinate of that point P, which is representing z as r cos theta and r sin theta. Okay. So this complex number P can be represented by, so in polar form, complex number z is given by z is equal to modulus of z into cis theta. Okay, where modulus of z you already know is r, cis theta means cos theta plus I sin theta. So in short you can write it as cis theta. Okay. So this is the definition of the polar form of a complex number. So I hope you will remember it. So where r is the argument of z, r is the modulus of z, where modulus of z is equal to r and argument of z is equal to theta. Okay. So then this will represent the complex number z in the polar form. So I hope you will remember this, right? Now exercise example 1 we are going to solve, right? So to solve that question, so I am going to solve that question. So look here, in the answer I will write first one, be careful about it. Convert the Cartesian form without using a calculator. So convert to the Cartesian form without using calculator. Okay. So this complex number 2 cis pi by 2 is in the polar form. So we can write 2 out and cos pi by 2 plus I sin pi by 2, isn't it? Now you know that cos pi by 2 is 0. So 0 and sin pi by 2 is 1. So I. So therefore in Cartesian form the answer is 2i. Okay. This is the answer of the first part. Let me write the second part here, B part. 8 cis pi by 4. So this will be equal to 8 into bracket cos of pi by 4 plus I sine of pi by 4 according to the definition. So 8, please look at the board, okay. So 8 into cos pi by 4, 1 by root 2, sin pi by 4 is also 1 by root 2, okay. So this complex number will be 8 by root 2 minus plus I 8 by root 2. Now what you can do, you can rationalize this, okay, and after rationalizing you will multiply both of them by root 2 in the numerator and the denominator. So therefore denominator will be 2 and numerator will have root 2. So 8 root 2 by 2 plus I 8 root 2 by 2, because root 2 into root 2 in the denominator, look here, root 2 into root 2 will be 2 and this root 2 into root 2 will be 2, okay. Now cancel out 8 and 2. So you get 4 root 2 plus 4 root 2 I, okay. This is the Cartesian form of part B. Now let me write, let me draw this line. So I will solve the third one. C 4 cis pi by 6, okay. So in full if you want to write, it is 4 cos of pi by 6 plus I sine of pi by 6. Pi by 6 means 30 degrees. So cos 30 degrees is root 3 by 2 and sine 30 degrees is 1 by 2. So your answer is 4 root 3 by 2 plus I by 2. So we can simplify the real part. So 2 root 3 plus half into I. So this is the answer of part C, okay. So part C is 2 root 3 and plus 2I. So I hope you understood this. Then part D, I am going to do it here. Root 2 into cis minus pi by 4. So now look here, it will be root 2 bracket cos of minus pi by 4 plus I sine of minus pi by 4, right? Yeah. Now look here, negative sign of cos becomes positive. So it is cos of pi by 4. A negative sign of sine will come out. So it will be negative I sine of pi by 4. Sine pi by 4 is 1 by root 2 as we have seen earlier. So 1 by root 2 minus I 1 by root 2. Now multiplying by root 2 to both of them will give you 1 minus I. Okay. So this is the Cartesian form of part D. Root 2 into cis minus pi by 4. Okay. So in that way you can find all of them. Okay. So I will leave D, E and F as a homework for you. So you can try all of them. Okay. Now look here. This is state the value of cis 3 pi by 4. What is the value of cis 3 pi by 4? Okay. So this will be, so let me solve the first part, cis 3 pi by 4. Now let me write it in full. It will be cos 3 pi by 4 plus I sine 3 pi by 4. Okay. Now look here, cos 3 pi by 4 is in the second quadrant, and in the second quadrant it is negative 1 by root 2. And cos sine will be positive 1 by root 2. So this is the answer, negative 1 by root 2 plus I into 1 by root 2, or you can write minus 1 by root 2 plus 1 by root 2 into I. This is the Cartesian form or the value of this complex number, right? Let me do part B here. Cis 0. So the angle is 0 here. So cos 0 plus I sin 0, right? So it will be cos 0 is 1, sin 0 is 0. So 0 into I will be 0. So the answer is 1. Okay. So I hope you understood this, right? Now C part of this. C part is modulus of cis theta. Means we have to find the modulus of cis theta for any theta. Okay. Now for any theta you have to find cis theta, right? So how to find cis theta? It will be modulus of cos theta plus I sin theta, right? And then cos theta plus I sin theta in the modulus form gives you cos square theta plus sin square theta. Okay, and I square also, because there is I also. So it gives you cos square theta minus sin square theta, because I square becomes negative. So cos square theta minus sin square theta. Now cos square theta minus sin square theta will be what? Cos square theta minus sin square theta will be cos of 2 theta. Okay, you can write cos of 2 theta, or you can leave it like that, right? And this can be for any angle they are asking you. If both of them, if you want to find the modulus, then modulus is like that. Okay. Okay. Now let us see the properties of cis theta. So 3 useful properties of cis theta. This is also something like logarithmic function. So cis theta times cis phi. Cis theta times cis phi is equal to cis theta plus phi. Cis theta divided by cis phi is cis theta minus phi. Cis theta plus 2k pi, k into 2 pi, means it has, if it has a multiple of, even multiple of 2 pi, then it is equal to cis theta, because 2 pi means cos of theta plus 2 pi is cos theta, and sin of theta plus 2 pi is also sin theta. So therefore it will make no difference and it will remain the same. So let us solve this questions now, these example number 3. Okay. So example number 3. Okay. Yeah. So first part, I will do few of them. Cis theta into cis 2 theta. Okay. There is multiplication of both of them. Cis theta into cis 2 theta. Now if there is multiplication, we can change it to addition, but we write cis together. So theta plus 2 theta. Okay. Multiplication changes to plus and the answer will be cis 3 theta. Okay. Like this we get the first part. The second part will be cis 3 theta divided by cis theta, and that will be cis 3 theta minus theta. Look here, the properties I have already explained it to you. Cis theta by cis phi becomes cis theta minus phi. Okay. So cis 3 theta minus theta will give you cis 2 theta. Okay, now C part of it. Cis theta to the power 3. Okay. There is q in the power. Okay. So now it will be cis theta multiplied by cis theta multiplied by cis theta. You can think of it like that. Okay. and because multiplication changes to plus, so it will be cis theta plus theta plus theta. Okay, and or whether we will use the first two first. These two together let us write. So cis 2 theta, and let us keep this as it is because we know about the two of them. Now again these are two of them, so cis 2 theta plus theta, and which will become cis 3 theta. So look here, when there is power 3, it goes and gets multiplied to the angle, okay, to the argument. Okay, so remember this property of polar form. Then D part of it. So D onwards, it is the same thing as I have explained, but let us do D, E and F. So D is okay. D part is cis pi by 18 into cis pi by 9. So as we know the property, multiplication changes to plus, so cis pi by 18 plus pi by 9, and this will have LCM 18, so pi plus 2 pi, so 3 pi by 18, 3 pi by 18, which will become pi by 6, cis pi by 6. Okay, now cis pi by 6 we can convert it to the Cartesian form, so cos pi by 6 plus I sin pi by 6. Pi by 6 is 30 degrees, so cos 30 degrees root 3 by 2 plus I sin 30 degrees is 1 by 2. Okay, so the answer is root 3 by 2 plus 1 by 2 iota. This is the answer of it. Okay, then I will do one more. E is 2 cis pi by 12 times cis pi by 6. Now look here, in this case there is a multiple 2, so that will remain out, and then we will simplify both the cis, so they will come together and they will get added, the arguments will get added. So it will be 2 cis, 12 is the LCM, so pi plus 2 pi, so 3 pi by 12 will be pi by 4. Okay, 3 will cancel with 12 and you are going to get pi by 4, and pi by 4 we know it is cos pi by 4 plus I sin pi by 4, and pi by 4 is 1 by root 2. So this will be 2 into 1 by root 2 plus I 1 by root 2. When you multiply 2 with 1 by root 2, you get root 2 in the numerator plus root 2 in the numerator here also. So like that, this is the answer of E part. What is F part? 2 cis 2 pi by 5. Yes, I will show you F part also. Two cis 2 pi by 5 into 4 cis 8 pi by 5. Okay, 4 cis 8 pi by 5. Now look here, when the modulus is multiplied, it remains multiplied. So we will multiply this. This is the modulus of first one, this is modulus of second one. So 2 times 4. So we write 8 and the cis will come together and will get added. So 2 pi by 5 plus 8 pi by 5 and they will be 8 cis 2 and 8, 10 pi by 5, 10 pi by 5 will be 2 pi, okay, and we know that cos 2 pi plus I sin 2 pi is going to become 8 into minus 1 plus 0, I into 0, because sin 2 pi is 0. So therefore the answer is minus 8 only, okay. Cos 2 pi, not pi. So I took it as pi, so it will not be negative, it will be positive. Okay, then with this we end this session. So I hope you enjoyed it. Yeah, there were so many things here, so please go through it, and I kept few things for the homework, so try them. So with this I will end this lesson. That's it for today. If you have any suggestion, if you have any comments, how should I, what topic should I cover next, or should I do more questions, or should I start the past paper questions? So let me know on my email ID or on my WhatsApp. Okay, the PDF of this explanation is there in the description box. The link is there. So okay then, bye for now.